2.5b, implicit differentiation. So the first one we're going to work with is 3 times the quantity x squared plus y squared, quantity squared, is equal to 100xy. And we're going to find the slope of that at 3, 1. Now, if you look at the graph, it's kind of a cool graph. It looks like an infinity sign and rotated 45 degrees. It's kind of nifty. All right, and we're going to find the slope at whatever point I feel like it. And this one's going to be 3, 1. All right, let's take a derivative. So what gets brought out in front? A 2, so it becomes 6. And then I have x squared plus y squared to the power of 1. And then what pops out? Now I have to take the derivative of the inner composite. So what's the derivative? 2x plus 2y, what? dy dx. There it is. So that's my left side. Is equal to, what rule am I using here now? The product rule. All right, just because we learned the chain and now we have implicit, they're all going to start working together. All right, so now we're using the product rule. So the derivative of my first, so my first I look at is 100x. So what's the derivative of my first? 100. And then times y, plus the derivative of my second. So my second I see is y. So I end up with dy dx times the first of 100x. All right. And so just like number 24, I have to distribute in there to get to dy dx. You following me? All right, so let's distribute in there. Bless you. So we're distributing that. So now I have 6 times 2x, which we call 12x. And then I have times the quantity x squared plus y squared still. And then I have 6 times 2y, which we're going to call 12y. And then I still have x squared plus y squared dy dx. And then on my right side, I can't really do too much, so I have 100y and then plus 100x dy dx. All right, pretty good. So now I'm going to shift some things around. So this 12x, x squared plus y squared, I'm moving that to the right. And this 100x dy dx, I'm moving to the left. All right, so now on my left, I would factor out my dy dx. And I have 12y times the quantity x squared plus y squared. And then minus what? 100x. Minus 100x. All right. I already just factored out my dy dx, so I didn't have to do it. All right. And then that's going to be equal to 100y minus 12x times the quantity x squared plus y squared. All right. And then what's my last step? Divide. So now I have dy dx is equal to this 100y minus 12x times quantity x squared plus y squared over the 12y times x squared plus y squared minus 100x. So that's what my slope is. So that can find my slope of anything on that infinity sign. All right, it's not technically called an infinity sign, but I'm going to call it that. All right, so I can find my slope at anything. But I'm going to find my slope specifically at the point, what? 3, 1 right here. So let's do it. So dy dx at 3, 1. So let's substitute in. So I substitute in 1 in for y. So now I have 100 times 1, which is 100. Minus, I substituted in 3 for x, so 12 times 3 is 36. So now I have 3 squared plus 1 squared. So 3 squared is 9, 1 squared is 1. We add them together, we get 10. Over, so 12 times 1, which is 12 times 10, minus 300. All right. So 100 minus 360 is what? Negative 260. And then 12 times 10 is 120 minus 300, which is negative 180. All right, so I have a negative, negative, so those go away. And so what could it simplify to? We can divide everything by 20. 20 over 20, which is? 13 over 9. So my slope at the point 3,1 is 13/9. All right, pretty nifty? All right, fantastic. We're moving. Here we go. All right, so now I have x squared plus y squared equals 25. That's the equation of a what?
Circle.
A circle. That's the equation of a circle. Centered at 0, 0, and my radius would be 5 on that. And I need to find the second derivative. But we're going to evaluate the first and second derivatives at the point negative 3, 4. All right, so I need to get to a second derivative. But first I need to find a what? A first derivative. So let's take a derivative. What's the derivative of x squared? 2x. What's the derivative of y squared? What's the derivative of 25? 0. So dy dx is equal to what? Negative 2x over 2y. And because I'm using it, I personally would simplify it. So I end up with negative x over y. Now, this is asking me to evaluate the first and the second at that point, so we're going to do it. So dy dx at negative 3/4, is what now?
3/4.
3/4. All right. All right, so when we substitute it in, negative, negative would be a positive. All right. All right, now we need to find the second derivative. So I need to find d2y over dx squared. Only one away from a jerk. All right. So here's my dy dx. My dy dx is negative x over y. What rule would I use to get to my second derivative? The quotient rule. Wow, this is like, we've already done the power, we've done the product, we've done the quotient, we've done the chain. Oh my gosh, this is a good review. All right, so now we're going to use the quotient rule. So the derivative at the top is what? Negative 1 times bottom of y minus the derivative of the bottom. What is the derivative of the bottom? dy dx times the top of negative x over y squared, the bottom squared. Well, this is something that's been tested in more often in recent years. Like the past 4 years, they've been hitting this decently on the AP exam. What do we do now? I've never seen this thing before. Well, I have. You have. What's wrong with this second derivative? There's a dy dx. Well, what is a dy dx? What is dy dx in this case?
Negative x over y.
Negative x over y. That's what it is. So I'm going to take this, and I'm going to substitute it in right there. And that's something that they've been testing in more recent years. All right? So we need to be looking out for that. So now I have negative y, and then minus x over y. Minus a negative x over y times negative x, all over y squared. Now, I'd like to simplify that up a little bit. So I have a negative, negative, negative. So that's just going to be a what? A negative. So now I have a negative y minus x squared over y squared. So right now, that's my second derivative. However, if you look at a multiple choice question, that will not be your answer. They will not have a complex fraction, or what I like to call fractions. So how do I change it? I multiply by the denominator in that complex part. So I need to multiply by y over, I just can't multiply the top by y. I can't do that. That's illegal. Y over y. I need to do both. All right, we're just changing the way it looks. All right. Guys, let's catch up. So we're going to distribute this y. So we have negative y times y, which is negative y squared. And then minus x squared over y cubed. And so that is what my second derivative is right now. All right. And now it tells me to evaluate it at negative 3, 4. So d2y over dx squared at negative 3, 4. So now we're going to substitute it in. So what is my y? My y is 4. So now I have 4 squared, which is, so now I have negative 16 minus negative 3 quantity squared is 9 over 4 cubed, which is 64. So then I end up with negative 25 over 64. All right. Pretty good? All right. Now, we don't have big terminologies for what a second derivative is yet. However, this is the change of the slope. That's what you can kind of think of it right now. All right. That is the amount of the slope changing at that point. All right. We're moving. So, after your derivers test, you're going to get a circuit. And I want to do 2 of them on your circuit with you right now. All right, so when you get to them, you should have the right answer. All right? So here we go. For this relation, find the value of what? X. We're going to find the value of x, for which dy dx is equal to 17 when y is equal to 8. So they're giving me dy dx, they're giving me y, but I have to solve for what? X. So it's a little bit backwards from what we're used to, and that's okay. All right? And so now we're going to get working. So it gives me dy dx, so it makes me take a derivative. So let's do it. So what comes out front when I'm taking a derivative of that square root? A 1/2 comes out front. And then I have x plus y to the what? Negative 1/2. But then what pops out by the chain rule? A 1 plus dy dx. Very good. Is equal to, what's the derivative of 3x? 3. All right. Now, if I actually had to solve for dy dx, I would distribute, right? I'd distribute, start working with it. I don't have to. They give me dy dx. I personally would substitute in right now. All right. Now, what gets to stay up top in my numerator on that fraction?
1/2 and 1 plus 17.
1 plus dy dx. The 2 is going to the basement. All right. And so I'm going to start substituting in now. So what goes up in my numerator? If I substitute in 17, I'd have 1 plus 17, which is 18. So 18 is my numerator. And then I have 2, and then I have square root. I don't know my x. That's what I'm solving for. So x goes there. And then what's my y? 8 equals 3. And now we just have to do a little bit of math. All right. All right. So lots of ways to tamper here. Which way you want to go? 18 divided by 2? All right. 18 divided by 2 is 9. And so now I have that over the square root. And then we could divide by 3, multiply by x plus 8, or square root x plus 8. So we end up with getting 3 equals the square root of x plus 8. Are we there yet? What does x equal? X equals 1. All right. You see how we had to kind of go backwards on that one? All right, pretty nifty. All right, we'll do one more. I need a reader. Thank you so much, Josiah. I like your reading voice.
For the circle centered at the origin with radius 4 and equation x squared plus y squared equals 16, find dx dt
Woo!
at the first quadrant point where x equals 2 and dy dt equals -3.
All right. So they are asking me to find what? Dx dt. And this is going to lead into our lesson on Tuesday. So I'm taking a derivative with respect to who? Time. With respect to t. Do any of my variables match up now? No. How rude. All right. So let's take a derivative. What is the derivative of x squared? 2x. What? I'm taking it with respect to t. So what pops out? Dx dt. Plus, what's the derivative of y squared? 2y dy dt. Exactly. Is equal to 0. Now, I'm going to start substituting in and see when I get stuck. All right? Because we're going to get stuck, and that's okay. So I have 2 times, what's my x? 2. So I end up with 4. I'm solving for dx dt, so I don't know that one yet. And then plus 2 times, what's my y? I don't know that yet. However, I do know my dy dt. What's my dy dt? -3. So I'm going to put that there. But I don't know my y yet, so we're going to solve for it. Well, here's my equation. What just happened? Here's my equation. This x squared plus y squared equals 16. I get an x. So if I substitute an x right there, what do I get? 4 plus y squared is equal to 16. Well, y squared would equal what? 12. And then we do what? We square root it. So y is equal to plus or minus square root 12. Now, which one do we want? We want the positive square root 12. However, x can equal 2 and y could equal negative square root 12 in which quadrant? The fourth. If they said fourth quadrant, guess which one I'd go with? Negative square root 12. Did you catch that? All right. So we're in the first quadrant, so we're going with square root 12. So now I have square root 12 there. And so now we're just going to manipulate. So we're going to move this to the right side. So I end up with 6 square root 12 is equal to 4 dx dt. Well, how do I solve for dx dt? Divide by 4. So there is what dx dt is. Now, I personally would be fine with it, just like that. However, we went a little step further if you're trying to look for your answer choice. Who's perfect in square root 12? 4. So who gets to come out? 2. A 2 gets to come out. So 6 plays with the 2 to give you 12. And then who stays in? Square root 3 all over 4. Well, 12 over 4 is what? 3. So I'd have 3 square root 3. All right. And you get a circuit for the weekend.